Friends, ready to understand the topic dielectric molecules. The molecules which does not allow to pass electric current through them, but they allow to pass electric field are said to be dielectric molecules. Such substances have no free charge carriers. Insulators and bad conductors are known as dielectric molecules. So, dielectric molecules are substances which does not allow to pass electric current but allow to pass electric field through them. They have no free charge carriers. They are bad conductors, or you can say insulators. So just you have understand what is dielectric molecules. Now you are going to understand type of dielectric molecules. Type of dielectric molecules. There are two types of dielectric molecules. Its types are two. One is said to be polar dielectric molecules. Another is said to be non-polar dielectric molecules. You have example of polar dielectric molecules. They are HCl, we have H2O, water, we have CO, carbon monoxide, CH3OH, etc. These are example for polar dielectric molecule. For non-polar dielectric molecule, we have example H2, you have example N2, you have CO, carbon monoxide, you have O2, you have CH4, methane, etc. These are the example of polar and non-polar dielectric molecules. Now the question is, what is polar dielectric molecules? Polar dielectric molecules are the molecules in which center of mass of positive and negative charge do not coincide. This means that positive and negative charge are separated. Here we have plus charge, here we have minus charge. This is the shape of polar dielectric molecule. So it have a plus charge here and minus charge here. So you have a dipole moment, and you know that dipole moment is directed from minus to plus charge. So this is the direction of dipole moment. This dipole moment is due to molecule inside the substance. So it is said to be intrinsic dipole moment, and its shape are asymmetric. Their shapes are asymmetric. Let us understand more clearly by taking an example. Suppose I am taking example of HCl. Then for HCl you have H plus H, delta plus here, delta plus, and you have a bond, and we have a Cl with minus delta here. So minus charge is here and plus charge is here. From minus to plus charge there is a dipole moment. So it is said to be intrinsic dipole moment. Let us take another example of water, H2O. For H2O we have one O, we have 2H, 1H is here, 1H is here. So we have plus H plus H minus, and we have minus 2 delta here. So from minus to plus we have P1, this is dipole moment. Here we have P2 dipole moment. So this is two vectors acting from a same origin. So this will be the resultant vector P, and P is said to be P1 plus P2, which is not equal to 0. So this is said to be the dipole, intrinsic dipole moment for water, and this is said to be intrinsic dipole moment for HCl. So they have intrinsic dipole moment. So these are polar dielectric molecules. Now, non-polar dielectric molecules. Non-polar dielectric molecules, center of positive charge and center of negative charge are coincide. This means that here we have a plus charge, here we have a minus charge. Let us put the dot here. This dot indicates that both center are coinciding in this dot. This is said to be non-polar dielectric molecule. Its shape is symmetric. Shape is symmetric. And here the shapes plus here, minus here, one dot here, one dot here. This is said to be asymmetric. This is for polar molecules. And this is for non-polar molecules. Now, if you draw the intrinsic dipole moment, if you learn to understand intrinsic dipole moment for non-polar dielectric molecule, then let us take an example. Let us take an example of CO, carbon dioxide. So put here C, put here O, put here O. We know the double bond is there. So we know here we have a minus delta, here we have minus delta, here we have plus 2 delta. From minus to plus we have P1. From minus to plus we have P2. So we have resultant P equals to P1 plus P2, and this P1 magnitude and P2 magnitudes are same. So I am writing here. This is here you have P1 magnitude equals to P, and this is towards positive x-axis. So this is Pi cap, and P2 magnitude equals to P. This is towards negative x-axis. So minus I cap. So you have P equals to P1 plus P2, puts the value of P1 is Pi cap and the value of P2 is minus Pi cap. So this sum up to be 0, and thus you have seen that intrinsic dipole moment for non-polar dielectric molecules is 0. Thus you have learned what is polar and non-polar dielectric molecules under the heading dielectric molecules. Next you are going to learn polarization of dielectric molecule. When the dielectric molecules are kept inside an electric field, then there is a separation of positive and negative charge, and they align towards one direction. This phenomenon is said to be polarization of dielectric molecule, which you are going to see in my next video. Do like, subscribe and share my channel.